Hey class! Today I will be teaching you about arrays and why you should care about them. Before we start, I just want to note that this video assumes that you are already familiar with variables, loops, and primitive data types such as integers and strings. Before we get into arrays, let me first introduce you to my colleague, Professor Ida No Math. Ida here is a math professor, and she has a problem that she is hoping you all can help her out with. Ida had just finished grading her latest math test when she noticed that, she made an error on one of the test questions. Not only that, Ida is not the most organized person, so her students' tests are scattered everywhere on her desk. So one by one, she sifts through the students' exams and updates each student's exam grade. Ida realizes this is inefficient, so she decides to write some code to accomplish the same task. First, she stores each student grade in their own variable. Then, she updates each variable to reflect the new grade. Unfortunately for Ida, this is just as inefficient as before. This might work okay for 5 students, but what if Ida had 100 students? Then, she would have to create 100 variables to store the student grades, and if she wanted to change each grade, she would have to write 100 new lines of code to reassign those variables. While Ida is in her office trying to sort out this predicament, suddenly, one of her students, Student 42, shows up and is like, "Yo, prof, where's my extra credit?" Oh no. Ida totally forgot to give Student 42 their 5 extra credit points when she first entered their score. So now, Ida has to look through all of her 100 variables to find Student 42's original grade, so she can figure out what the updated grade should be. Grades are due tomorrow, so time is running out for Ida. Can you help Professor Ida No Math get out of this mess? We'll get back to her later. First, let me tell you about arrays. An array is a data structure that can store collections of items. Arrays have the following properties: contiguous memory allocation, order, homogeneity, and random access. Let's go through each of these properties more in depth. Contiguous memory allocation means that array elements are located next to each other in memory with no gaps. So, if this gray rectangle represents the total memory allocated for the array, this might represent the memory allocated for each element, and you'll see that they are right next to each other with no gaps. Arrays have an order and can be indexed. Here, I've labeled our array diagram with indices. Some programming languages have array indices that start at 1, but most programming languages are 0 indexed, which means that counting starts at 0 instead of 1, and that goes for array indices as well. I've updated our array diagram to reflect this, and I will be using 0 indexed arrays from this point on. Homogeneity means that array elements must be of the same type. So this array of cat names is valid because each element is a string. This array of my favorite booleans is also valid because each element is a boolean. However, this array of things that rhyme with moo is not valid because it contains strings, numbers, and booleans, which means it is not homogeneous and therefore not a valid array. Lastly, arrays are random access, meaning we can access each array item directly using its index. This is in contrast to data structures like linked lists, stacks, or trees, where we can't access every item directly. I've brought back our cat names array to demonstrate what random access looks like in code. First, I declare our cat names array. Then, just by using the index of an element, I can return the cat name at index 4, which will get us Grumpy. Remember that our array is 0 indexed, so the cat name at the 4th index is actually the 5th cat name. I just want to make a quick note on array length. Some arrays, called static arrays, are of fixed length. This means that once you declare the array, you cannot change the length. Other arrays, called dynamic arrays, are resizable. This means that after you declare the array, you can still make the array longer or shorter later on in the program. I'm not going to go more in depth into the differences between static and dynamic arrays in this video, but I wanted to make a note of this because different programming languages have different implementations for arrays, and some may use static arrays whereas others may use dynamic arrays. Lastly, I'm going to go over array iteration, which is one of the most useful functions of arrays. Here I just have the array of my favorite booleans, and since making this array, I've had a major change of heart. I want to flip all of my favorite booleans, so I want to make each false into a true and each true into a false. Here I've written some code in Java to accomplish just that. Before we get into the iteration, I want to point out the array properties we can see just from the Java syntax. When you declare an array in Java, you have to provide the type of elements in the array. This forces the array to be homogeneous. Then we are using a for loop to iterate through the elements of the array. The reason we are able to do this is because contiguous memory allocation and order allows us to traverse the array elements easily. I also want to note that I chose to do this with a for loop, but you can accomplish the same with a while loop. Here, we are modifying the array elements by accessing the index of the element and then using the not operator to flip it. We are able to do this because of the random access property of arrays. Now that we understand how array properties enable us to do array iteration, let's run the code. We can see that after iterating over the array, all of my favorite booleans are flipped from their original values. Now, let's revisit Professor Ida No Math and her grading troubles. Recall that before, Ida was either sifting through hundreds of student papers or sifting through hundreds of lines of code, neither of which is ideal. Also, student 42 still needs their extra credit. In short, Ida wants to change all of the student grades efficiently and access any particular student's grade with ease. Can you identify and ideate the ideal idea for Ida? The answer, of course, is to store the student grades in an array. With contiguous memory allocation and order, it will be super easy for Ida to iterate over the array and change each student's grade, saving her the meticulous effort of manually checking and updating each grade. With random access, she can easily access student 42's grade and give them that extra credit. Ida is so excited about arrays that she immediately writes this short Java program to add 5 points to each student's grade and an extra 5 points to student 42. We can see that with the power of arrays, Ida was able to turn hundreds of lines of code into just 5. So, why care about arrays? One reason is that arrays can model a lot of things we care about in real life, such as student grades. In general, anything that is some sort of list can be modeled as an array. Some other examples include a shopping list or a closet of clothes. We can also have arrays inside other arrays, sometimes known as 2D arrays, and we can use these to model grids, such as a chessboard. Another reason why you should care about arrays is because arrays are the building blocks of a lot of other really useful data structures, for example heaps, hash tables, stacks, and queues. So, understanding arrays is essential for understanding many more complicated data structures. The last thing I want to talk about today is that the world of arrays is vast, and we have just entered it. There are so many more topics in arrays, such as static and dynamic arrays, array operations such as insertion and deletion, search, and sort, and array applications such as graph algorithms, image processing, and machine learning. This video covered the basic properties of arrays, but that's just the tip of the array iceberg. Some of this stuff I'll cover in future videos, but the world of arrays is so vast that I'll never be able to cover it all. So, if you found this video about arrays to be interesting, I really encourage you to explore some of these topics on your own. Let's summarize what we've learned today. First, we learned that an array is a data structure that can store collections of items. We learned that arrays have the following properties: contiguous memory allocation, which means that array elements are located next to each other in memory with no gaps; order, which means arrays have an order and can be indexed; homogeneity, which means that array elements must all be of the same type; and random access, which means that we can access each array item directly using its index. We learned that contiguous memory allocation and order allow us to iterate through an array, which we can do with a for loop or a while loop. We learned that we should care about arrays because arrays can represent a lot of things we care about in real life, such as shopping lists or chessboards, and arrays are also the building blocks of many other data structures, such as heaps or hash tables. Lastly, we learned that the world of arrays is vast and goes far beyond what we covered in this short video. Thank you so much for watching, and please, feel free to comment any questions you have about the video or any topics you would like me to cover next. I also welcome feedback for how I can improve my videos. As always, this is your CS Professor of Fun.